All right, hey everyone, we're here with the projectiles practice problems. And number 1 says, what is true about the horizontal velocity of a projectile assuming no air resistance? Well, horizontal velocity is always constant for a projectile. Since there are no external forces acting on it in the horizontal direction, again, we're assuming no air resistance, that horizontal velocity will remain constant throughout the entire flight of the projectile. Number 2, how does the vertical motion of a projectile compare with the motion of free fall? Well, they are one and the same, right? The vertical motion is free fall, so projectiles are in free fall vertically. Thus, their vertical velocity changes due to the acceleration of gravity, right? So v vertical is going to change due to gravity at a rate of negative 9.8 meters per second every second. Okay, number 3. In Mythbusters, why does a bullet fired and bullet dropped hit the ground at the same time? Again, we can say that the bullet dropped is in free fall, bullet fired is also in free fall, so they're both in free fall and being acted upon by gravity in the same way. You know, the other constraints there too are that they're dropped from the same height and they're dropped at the same time as well. All right, let's check out number 4 here. And from what you know about the horizontal and vertical motions, fill in these missing velocities. So let's see here. Hey, in question number 1, we said that the horizontal velocity is constant. So if it's 20 meters per second to start, it will always be 20, assuming no external forces, no air resistance. You know, there's nothing to push on the projectile this way to oppose that horizontal motion, so it'll just keep a constant velocity. For vertical velocities here, though, most of the Vy, or the V vertical velocity, initially is 0. 1 second later, it changes to negative 9.8, right? So Vy is going to be changing due to the acceleration due to gravity. And it'll always change by negative 9.8 meters per second. So we're going to have another change by negative 9.8 as we go to the next second. So that's going to be what? Negative 19.6 meters per second. In the next second, it'll change by negative 9.8 again due to gravity. So that's going to be 29 or negative 29.4 meters per second. And another second later, it's going to change by negative 9.8 meters per second again and be 39.2 or negative 39.2. And what's interesting about the 5th second, this is when it hits the ground. So its impact speed, it'll be going forward at 20 and downward at, oh, hold on, I didn't do it right, 39.2. I need to change it by another 9.8, so it's going to be 49 meters per second down here, or negative 49. All right, so we see our Vy is always going to change by negative 9.8 each second as it's falling in free fall. Okay, we have arrived at number 5. A kid throws a ball horizontally at 30 meters per second off a tower as shown. So let's sketch in the horizontal velocity here. So it's going to leave his hand going 30 meters per second and follow this parabola until it hits the ground. So we want to know how long it's going to take to hit the ground, and then what the range is, how far out from the tower it's going to land. Oh, there's the bell, everybody. Live at school here. All right, so for A, it says, how long does it take the projectile to hit the ground? So that sounds like I need to use the distance fallen is equal to 1/2 AT squared. And this is, what, 20 meters up? So if I do 20 meters, to fall 20 meters, I accelerate at 9.8 meters per second squared due to gravity. How long will it take to fall? So 1/2 9.8, I remember that's 4.9 t squared. And I'm going to have to divide that into 20. So if I divide both sides by 4.9, right, to get the t squared by itself, t squared will be, well, 20. That's 20 divided by about 5, right, which is about 4. But we're going to be accurate here. So I got 4.08. So if I square root both sides to find time, that's the time to hit the ground will be, I'm going to turn my phone the other way, 2.02 seconds to hit the ground. All right, so the range of the projectile then, so the horizontal distance, so that would be measured from here all the way out to where it lands, so that's the range. All right, since we know the velocity is constant horizontally, we can just use the average velocity formula here, because there's no acceleration in this formula. It's just distance over time, because it's not accelerating horizontally. So it's what, going 30 meters per second? Where is it? X marks the spot. Where is it? At 2.02 seconds. So I just have to multiply these two numbers, little cross multiplication. That's going to be around 60, right? So 30 times 2.02, yeah, I got 60.6 meters. And I did write the wrong variable there, so I'm going to backtrack it out, right? So that's the distance, that's the range. Change in x, 60.6 meters out. All right, number 6, we're going to do the same procedure, right? We got our cannon going. This is just like you guys in the activity. You got to choose your own stuff. So here's somebody that chose 6 meters high cannon and is going to launch it at 24 meters per second. That's like 50 miles an hour. We're really going for it here. And fly over Michelangelo's head right there, right? That's Michelangelo, isn't it? Right here? I think so. So where do we put the target? We'll hit that target. We'll go beyond the target. We'll fall short of the target. Let's find out. So how long does it take to hit the ground? Let's see. I'm going to do that work right here, actually. So how long it takes to hit. So again, it's going to fall a certain distance in a certain amount of time here as it accelerates. So it's going to fall 6 meters. 1/2. The acceleration gravity is still 9.8 as usual. We're still on Earth, everybody. Oh, I should have thrown in a moon problem, huh? Oh, that would have been cool. Moon projectiles. They did that. They hit a golf ball on the moon. True story. I don't know if it was a hole in one or not. All right, so 6, so 1/2, 9.8, that's 4.9 again, times t squared is going to equal 6. I got to divide both sides by 4.9 to get t all by itself. So 6 divided by 4.9 is, oh, well, t. Oh, hold on. 6 divided by 4.9. That's so not right. Calculator props. 6 divided by 4.9. Ooh, I got 1.22. So that's the time squared, though. So I have to square root that number. And the time to hit the ground is 1.1. It's 06. I'm going to round it. 1.11 seconds. All right, there's my time. So at that time, so if I'm traveling horizontally, again, the horizontal velocity is constant. So I can just use distance over time. There's no acceleration in that equation. Since, so horizontal velocity is constant. So 24 meters per second. Where is it going to be? X marks the spot at 1.11 seconds. So I just have to cross multiply this. I'm going to find the range. So times 24. Ooh, and I get 26.56 meters. So it is going to go off the chart here. It is going to go from here. If that's 20, it's going to land somewhere over there, right? So I need to put the target here for that to land. Bullseye. Thanks, everybody.